Unit 3 is all about investing. And we're going to keep it, we're going to do it in 3 stages. We're going to start out tonight and next week doing simple interest. So we'll spend 2 weeks on that. Simple interest is actually further reaching than most people think. There's way more things that use simple interest than most people realize, just because of some applications and some processes that it's used in. So that's going to be weeks 1 and 2. Our third week, I'll call that A instead of. We're going to hit our second topic for Unit 3, which is going to be compound interest. And then finally, we're going to spend a couple of weeks on annuities. And annuities are really kind of interesting because not only can you use the annuities for investing and withdrawing, but you can also use the annuity formula for figuring loan payments. It's referred to as something called a sinking fund. So let's jump into our compound interest. Sure. It's okay. That's, yeah, whatever. Thank you. The little hamster may be way off the wheel tonight. Simple interest. So looking at simple interest is just that. It is the simplest way that there is to figure out interest. In simple interest is calculated only on one of 2 occasions. End of the term, that is known as maturity. So in other words, that's when if you're investing money, the investment would end and you have to take the money back. Or if it's a loan, the loan is over and you have to pay the money back. Or the second is anytime there's an action on the account. Some terminology that we're going to look at. Present value is the value in the present. Yes, this is one of those timelines again. Future value is the value in a future. We're talking about simple interest. We generally refer to the present value or the starting amount as the principal, and the future value is the maturity. Maturity value. What happens in between there is interest. In fact, it'd probably be more appropriate to have one solid arrow because the interest only gets figured in once. Generally. I should be careful. There are exceptions to that. So we're going to start out talking about that interest. The amount of interest earned. First, we want to talk about the stated rate. Let's say your interest on the account is stated at 4%. They might use the term APR. What does APR stand for? Annual percentage rate. There you go. That term's going to come out quite often. And the key word there is annual. So that is 4% is an APR, that is 4% per year. And pretty much any stated rate, unless it is very, very specifically stated as otherwise, any stated percentage rate is for a whole year. So if we're dealing with periods shorter or longer than a year, that percentage rate has to be adjusted. Now, just like we had discussed when we did percents back in Unit 1, there are applications where the rate method of percent is more useful, just like with our markups. And this is one of them. We use a rate method when we talk about calculating simple interest. So that amount of interest, I, is equal to P, which is the principal, times R, which is the rate, times T, which is the time. Now let's do some defining here. I is the dollar amount of the interest. P stands for principal. That's that starting amount. R stands for rate. Remember, a rate is a percent as a decimal. And finally, T is time in. It makes sense that if our rate is a percent per year, T is the time in years. Yes. We'll get to that. Hang on. So, for an example here, let's say that Sam invests $5,000 at 4% simple interest for 2 years. Find the interest earned. Well, the formula, I equals P times R times T. Do we know P? The interest earned, by the way, is what we're looking for. That's I. That's what we're trying to find. P is the principal. That's the starting amount. How much is, they started with 5,000. Very good. Times, do we know R? 4%, but remember R is that percent as a decimal. Good, so 0.04. And T, 2 years, so it's 2. So if we multiply that all out, we get, what, 400 bucks? Does that look right? So $400 interest. That is the amount of interest. Now on top of this, I want to introduce a concept called find the maturity value. The maturity value, if you look up at that timeline, we're not going to scroll up to it, but you'll have it in your notes somewhere, is the amount at the end of the investment. Well, maturity value is equal to the principal plus the amount of interest earned. So in this problem, our maturity value is the $5,000 principal plus the $400 of interest earned, which comes out to be $5,400. Any questions? Banks do not like to do simple interest. They don't like to go more than a few months without calculating interest on an account. So to go 2 years like we did in this example on simple interest is not very practical. The banks just don't like to do it. They like to produce, they prefer to calculate interest every month. Generally, they won't go past 3 months without calculating interest. So it's more practical if we say that Peyton borrows $2,500 at 8% for 3 months. Now, we didn't say anything about simple interest or anything like that. If all it is said is 8%, we assume simple interest. If it was compounded, it would say compounded monthly, compounded quarterly, or something like that. Find the maturity value. Another way we could ask might be find the amount that Peyton would pay back. To find the maturity value, what must we find first? The interest. And how do we find the dollar amount of interest? There you go. PRT. Do we know P? 2,500. Do we know R? 0.08 from our 8%. Do we know T? There we go. We've said the time is always in years. Well, this is 3 months. So to make that years, there's 12 months in a year. So we write it as 3/12. So we multiply that out. What do we get? $50 in interest? Yes? Good. So then how do we find the maturity value? Perfect. The principal plus interest, 2,500 plus 50 is $2,550. Any questions? Pat invests $2,000 at 5.2% simple interest for 4 months. Find the amount, and I'll find the maturity value. I'll give you guys a couple minutes to do that one in your notes. Where do we start? Finding the interest. So the interest is going to equal perfect. The principal is 2,000. The rate 5.2% becomes 0.052, and our time of 4 months is 4 out of 12. If we multiply that all out, what do we get for our dollar amount of interest? $34 and how many cents? 32. How do we use that to find our maturity value? Add it to 2,000. So that is $2,034.32. Any questions? Stacy has an auto loan at 4% interest. Find the beginning balance for a month where Stacy paid $96 in interest. So our formula, interest was principal times rate times time. All we've done so far was find the interest. But in this case, $96 is the interest. We know the interest. We know I. Do we know the principal? No, the principal is the beginning balance at the beginning of the month. That's what we're trying to find. So I'll put P there. Do we know the rate? 4%, which will be written as 0.04. And do we know the time? 1 month, so 1/12 of a year. Now, to make this work, we're going to have to do some fancy calculator work. Otherwise, we get some round off errors. So now this is just an equation that we know how to solve. But before we start to solve it, we have to combine anything we can combine on either side. We can multiply the 0.04 times 1/12. What is 0.04 times 1/12? It's 0.0033333333333. 0.03 repeating, or 0.003 repeating. If I write that down and try to type it back in my calculator, there's going to be a round off error. So I'm going to do the 0.04 times 1 divided by 12 is 1/12. So I get that 0.00333333. So what I'm going to do is I'm going to not clear my calculator. I'm just going to leave that in my calculator. To solve this equation, what's going to be my next step? Perfect. I divide by that 0.03 or 003 repeating. So here's what I'm going to do. In my calculator, I'm going to type in 96 divided by, and all of you, most of your calculators at least should have an answer key on it. It's down by your equal sign, right next to your equal sign, there's the negative key. Above it, it says ANS. So what you need to do is you type in 96 divided by, then you press second and ANS. That's telling the calculator to take 96 and divide it by the previous answer. Hit enter and you get $28,800. So the principal or the balance at the beginning of that month was $28,800. What do you think? Good stuff. Yours, it should be right down there by that equal sign. The ANS key, it's the negative key in parentheses, right by your equal sign. There you go. Okay, so let's take a look at Alex earns $42 in interest for 6 months on a $3,500. Yeah, we better be more reasonable than that. Let's do a $7,000 investment. What rate does Alex earn? So I equals PRT. Where do we start? Do we know I? Yes, $42 is our interest. Do we know P? Yes, P is 7,000. Do we know R? We do not. Do we know T? 6 months, so it's going to be 6/12. We can only have one value that we don't know. So once we knew we didn't know R, we had to know T. Now, before we solve this, what do we have to do? What's our first step? Combine the 7,000 times 6/12, which is 3,500. So then we're going to divide by the 3,500. What'd you get? 0.012 equals R, which is 1.2%. Now I get the question all the time. This one was a nice terminating decimal, 0.012. Where should I round that otherwise? Go to at least 5 decimal places. Why do I say at least 5 decimal places? Well, if you look at it, the first 2 decimal places here are the percent. That's what's in front of the decimal point once you make the percent. You move the decimal point 2 spots. And a standard, usually the problems will either round to the nearest tenth or the 100th of a percent. So the 10th would be the 2, 100th would be one more place beyond that. So in order to round to 100th of a percent, we have to get at least that one place beyond that 5th decimal place. What's that? Don't do that. You okay? Okay. It will be tomorrow morning. It won't break till I talk to the lawyer. Okay, so Kim borrows $12,000 at 9% interest. If Kim wants to pay no more than $270 in interest, how long before Kim must repay? So it's the maximum length of time Kim can go and keep the interest still at or below $270. Do we know I? That's 270. Do we know P? It is 12,000. Do we know R? It is 0.09. 9% is a decimal. So apparently we're finding T. So we have to do some combining here. 12,000 times 0.09 is what, 1,080? So 270 equals 1,080 T. Then what? Divide by 1080. We get T equals 0.25. What does that mean? A quarter of a year. If we wanted in months, how would we find that in months? There's 12 months in a year times 0.25 would be 3 months. Does that make sense? Okay, we'll pause for you. No problem. Okay, so next, I'm going to have you guys try one in your notes. If Sam invests $1,500 at 8% interest, how long does it take for Sam's money to double? I'm going to give you a second to think about that one and work on it. Then we'll talk. Peak. Some of you might have been looking at this one thinking there's not enough information, but there is. What is the amount of interest earned here? Well, the dollar amount, though, for I. 1,500. The balance is going to have to go to 3,000. But to double, the interest would have to be 1,500. Of course, the principal is also 1,500. The rate is 0.08, and we are looking for the time. 1,500 times 0.08 is what, 120? Then we divide by 120, and we get 12.5 equals T, and of course that stands for 12.5 years, or 12 years, 6 months. 8% interest, it takes a while to double when you're doing simple interest. Oh, let's see here. Chris, let's go ahead. Time is always in years. T is always years. Chris borrows money for 3 months at 6% interest. How much did Chris borrow if Chris pays $45 in interest? I'll give you a couple minutes to work on that. Do we know the interest? What is it? $45. Do we know the principal? No, we do not. Do we know the rate? 0.06. Do we know the time? 3/12. So we combine 0.06 times 3/12, 0.015, and then divide by 0.015, and you are correct. We get principal of $3,000. What do you think? Better than a sharp stick in the eye? Kyle borrows $9,000 and pays $180 in interest for 4 months. What rate is Kyle charged? Find the interest rate. I'll give you a couple minutes. So interest equals principal times rate times time. Do we know the interest? 180. Do we know the principal? 9,000. Do we know the rate? No. Do we know the time? 4/12. And then what? So the 9,000 times 4/12 is 3,000. So divide by 3,000. We get 0.06 equals R, which does come out to be 6%. Pete borrows $9,000 at 7% simple interest for 90 days. Find the maturity value. Of course, the difference here is I'm not asking for my time in months, not asking for it in years. I'm giving the time in days. So interest equals PRT. We're looking for maturity value, so we first have to find the interest. Principal is 9,000. The rate is 0.07. The time is going to be 90 over. You would think it would be 365, wouldn't you? There is something called exact interest. If it were exact interest, it would be 90 over 365. That is the exact amount of interest. But then there is something else called ordinary interest. Ordinary interest, they figured, is 90 out of 360. Why a 360? Very good question. Why on earth would they decide to alter the number of days in a year? Well, back in the good old days, I mean, we're so used to just punching buttons on a calculator or throwing it in a computer, but those weren't always there. Those have really only been around for about the last 50 years, 50, 60 years. There were mechanical adders and stuff like that before that that helped. But banks go back into literally the late 1700s in the United States. They had to figure out interest. Have you ever tried to divide out 90 over 365? No, it's a pain. Even if you calculate the interest for at the end of a month, a 31-day month, 31 out of 365, that's a real pain to calculate. So what they did is they made the assumption, they simplified time. Every month was 1/12 of a year, period. If the money was in there for less than, let's say they drew the money partway through the month and they had to figure out the interest before they let them withdraw it, well, by dividing by 360, it simplified the calculation. Look at how many things divide relatively easy by 360. 10, 5, 12, 18, 15. All of those numbers work relatively simple with 360. So by using 360 days in a year to figure it out, what they were doing was they're saying that month was 1/12 of a year and a month was 30 days. Whether it was a 28-day month, a 31-day month, or whatever, they figured that month is 30 days or 1/12 of a year. Now that we have, now this was all before calculators and computers and stuff. They did it to simplify it. They call that ordinary interest because that was the way it was ordinarily done. Now that we have computers and calculators, we're capable of doing exact interest. It's no more work to do exact interest than it is to do ordinary interest. So why on earth would a bank still want to do ordinary interest? Yeah, they get more interest. If I'm dividing by 360 instead of 365, this gives me a higher interest rate, a little bit more dollars in interest. So looking at this problem, is there any way to tell whether it's exact or ordinary interest? No. So the assumption is, if it is not stated, you always assume ordinary. Always assume that it's going to be using 360. So that amount of interest is going to be what? Well, it's 9,000 times 0.07 times 90 over 360. Gives you $157.50 is the interest. I asked for maturity value? Yes, I did. So now we have to do the maturity value, which is that 9,000, 157.50. 9,000. Come on, there we go. $9,157.50. Any questions? Let's redo this. For exact interest. If it doesn't say, always assume ordinary, but it might say exact. Sure. Unless you're told exact, always assume ordinary. So 9,000 times 0.07 times 90 over 365. we punch that in, we get $155.34. Notice they get $2.16 less interest. That's why the bank would stick with ordinary interest, even though the computers will do exact. Okay, it is 6:20, so it is time to take our break. Let's do that, and we will start up again at 6:30. So, with this idea of ordinary and exact interest, we're going to talk about, no, it's okay. Lane borrows $5,200 at 7.3% interest for 8 months. Find the exact interest. I'm going to give you guys a couple minutes to do that one in your notes. So, we're looking for the exact amount of interest. What are we going to put in for the principal? $5,200. What's going in for the rate? 0.073. What's going in for the time? 8/12. $253.07. Let's say that Corey invests $4,100 at 4.75% interest for 150 days. Find the exact amount of interest. So I'll give you a minute to work on that one. So I equals perfect. 4,100 is our principal. Our rate is 0.0475. 150 days. Why is it over 365? Says the word exact. So we multiply that out, 4,100 times 0.0475 times 150 divided by 365. $80.03. How much interest would be paid on $5,800 borrowed at 9.5% for 165 days? I'll give you a minute to figure that one out. So I equals 5,800 0.095 for the 9.5 times 165 over 360. Why 360 that time? Because it doesn't say exact, so we assume ordinary. Very good. We multiply that out, what do we get? $252.54. Very good. Sam borrows $2,300 at 11.9% on May 7th. How much would Sam repay on July 18th? Now, of course, I have dates in there, which means we're pulling out the book and looking at that magic little chart, I believe on page 396. What day of the year is May 7th? 127. What day of the year is July 18th? What is it? 199? Okay. So that means the number of days that have gone by, 199 minus 127, is 72 days. So our interest is 2,300 times 0.119 times 72 over 360. What does that give us? What's that? Oh, sure. We look up the date for both of the dates. There's a number in the chart. So May 7th is the 127th day of the year is what that chart is telling us. And July 18th is the 199th day of the year. So subtracting those gives us there's 72 days in between them. So you get $54.74 in interest. Okay, we all done? How much does Sam repay implies we're looking for maturity value. So that's the principal of 2,300 plus the interest. So it's $2,354.74 is the amount that is repaid. What do you think? Still better than a sharp stick in the eye? No? You getting there? Which is a better deal? Paisley wants to borrow $7,500. Bank A, I should say she wants to borrow $7,500 for, we can see where your mind is, 210 days. Talk to me after class. I might be able to hook you up. Anyway, Bank A is offering 8.25% ordinary interest. Bank B is offering 8.29% exact interest. Which is a better deal? I'm going to give you. So the difference here, when we set them up, Bank A is going to be 0.0825, but it's only divided by 360. Bank B is 0.0829, but it's divided by 365. So we really have to calculate these out. Bank A is going to be $360.94 in interest. Bank B is $357.72. So Bank B is going to be slightly cheaper, even though the interest rate is higher, because it's calculated exact instead of ordinary. Actually, now it's more and more common for them to switch over to exact. Partly because federal regulations. Now, I just said earlier that banks don't use simple interest for much of anything that goes long term. But there are some things that they do use simple interest for that might be kind of surprising to you. One of which is a mortgage. Most banks do mortgages on simple interest. The second one, auto loans, car loans. Now, if you remember, we said interest on a simple interest is only calculated when one of two things happens. Do you remember what they were? You can in a few minutes, huh? One of them is at the end of the term, any action on the account. There's the key right there, an action on the account. What does a bank expect you to do every month on a mortgage or a car loan? Make a payment. When you make your payment, that is an action on the account. That triggers an interest calculation. So your interest is calculated and added to the balance before your payment is figured in. This is all part of a process called the U.S. rule. What the U.S. rule is it's a regulatory process for calculating partial payments on a loan or an account. Part of the U.S. rule is we use ordinary interest. Now, there are some banking regulations that have changed that. There are certain places where they're required to use exact interest now. But we're keeping it simple here. And use the exact number of days. What does that mean? Well, that means you're still 365 days in a year. So if money sits there for a full year, you could actually be in a spot where you're using 365 over 360. Calculate your interest for a year. Does that make sense? So when you're looking up your days in the year, you're still using the 365 whole days. You're not going to cut off your year at December 26th. Okay. Well, let's look at how this all works is the U.S. rule. Pam borrows. We're going to keep this one a little bit simple. $8,000 at 7% interest for 90 days. On day 28, Pam pays $2,500. On day 59, Pam pays $2,000. Find the balance due at maturity. Maturity would be at the 90 days. And B, total interest paid. B is actually quite easy once we've done part A. So we start out day 0. The $8,000 loan occurs. What is the next action on this loan? Day 28. And that is an action of $2,500 payment. Before that payment gets made, the interest must be calculated and added into the account. So the interest is equal to, we had $8,000 loan times what's the rate? 7%, 0.07, times 28 over 360. Gives us, what, $43.56? I'll wait for you guys to confirm that. Yes? Yeah, sure. So the balance before the payment is the 8,000 plus the interest. So that's $8,043.56. Then we subtract the payment of $2,500. Did you get that number? 4350. Let me try it again. 8,000 times 0.07 times 28 divided by 360. I'm still getting 43.56. Did you use 360 with the bar? Gotcha. Okay. What type of calculator is that? TI? There's, on the next break, talk to me and I'll show you how to set the mode so it gives you a normal display. So this is the balance after the payment. $5,543.56. What's the next action on the loan? Day 59, and that is a $2,000 payment. Oops. Try that again. Now, before I do anything here, why did I do 59 minus 28? That's my days that have gone by. The first 28 days have already been used. So we can only do from 28 to 59, which is 31 days. So we're going to calculate our current interest. What's our principal? Perfect. That balance after the payment of $5,543.56. Our rate is still 0.07. Now it's 31 days over 360. What's that? Oops, that should be 56, shouldn't it? Thank you. So $33.42 is our interest. So we're going to take the previous balance, $5,543.56, and add the $33.42 to get the balance before the payment, which is going to be $5,576.98. Then what happens? The payment of $2,000. So that gives us a balance. Perfect. The balance after the payment of $3,576.98. What is the next action on the loan? Well, some might say there isn't one, but there's one that always occurs, and that is maturity. And that's going to be day 90. It's a 90-day loan, and at day 90, it's maturity. It is time up, ready to pay up, right? Why am I doing 90 minus 59? 59 days have already been used, so 90 minus 59 means we have 31 days of interest for us to figure out. What's our interest formula? I'll give you the 31 over 360 then, right? So that gives us $3,576.98, bless you, times my interest of 0.07, that's my rate, times 31 divided by 360. We get $21.56. But we're going to take that previous balance, $3,576.98, and we're going to add that you get $3,598.54. Now this isn't a payment, this is maturity, which means that amount is the balance due at maturity. So on that day, on day 90, that's the amount that has to be paid up. What's that? It is. That's part A. Part B is find the total interest. Well, there were three interest amounts, 2156 plus 3342 plus 4356, right? Which gives us a grand total whopping interest of $98.54. What do you think? You always have the option not to do it. Are we ready? Not yet? Okay, give me a second. Okay. Carl borrows $9,200 on March 23rd at 9.7% simple interest. On April 19th, Carl pays let's just go $3,000. On May 16th, he pays another $3,000. On June 19th, another $3,000. Carl pays the balance on July 20th. Fine. The balance paid on July 20th and the total interest. So you guys want to try this on your own? Okay, we'll do one more as a group before I turn you guys loose to try one. On your magic little chart on page 396, look up for me March 23rd. What day of the year is that? 80 what? 82, okay. 82. April 19th is what day? 109. May 16th. 136. And June 19th, 170, and July 20th, 201. Okay, so obviously our first action here is on March 23rd, and that is the $9,200 loan. What's our next action? April 19th, and that is $3,000 payment. First thing we need to find is our days. April 19th is 109, minus March 23rd is 82. That is 27 days. What's our next step? Find the amount of interest that's built up. So it's 9,200 is our balance. Our rate is 9.7%, so 0.097 times 27 over 360. All right, $66.93 in interest. Yes, perfect. So now I'm going to take that amount, add it to my 9,200 previous balance to get my balance before the payment. $9,266.93. And then, of course, we have the payment, $3,000, which will give us, perfect, $6,266.93. That is our balance after the payment. Our next action is on May 16th. May 16th is a payment of $3,000. What two numbers are we going to use to figure out the days? 136 and 109. So 136 minus 109 is 27 days again. You got a question? You got to figure it out? Okay. So then our balance that we're going to use our principal, use the $6,266.93 times 0.097 times 27 over 360. 6,266.93. You get what? $45.59. Of course, what are we going to do with that? Perfect. Add it to the 6266.93, which is going to give us $6,312.52, which is the balance before the payment. Then we're going to make the payment of 3,000, which gives us $3,312.52 is our balance after the payment. Our next action is on June 19th, and that is a $3,000 payment. So what numbers are we going to use to figure out the days here? 170 and 136. The June 19th and the May. That comes out to be 34 days. What do we do next? Find the interest. So I equals the $3,312.52 times 0.097 times 34 over 360. And that gives us $30.35. So that gives us our balance before the payment of $3,342.87. Then subtract the payment of $3,000, giving us a balance of $342.87. Next action is going to be July 20th. And that's going to be maturity, or at least paid off, right? Days. How do we figure our days? 201 minus 170 will be 31 days. And then find the interest. So it's the $342.87 times 0.097 times 31 over 360 gives us $2.86 in interest. We add that to that previous balance of $342.87 to get $345.73, which is balance due. That's the amount paid on July 20th. Total interest, if you add those all up, wait just 1 second. Should get $145.73. Is that what you need? $145.73 is what I get for total interest. Total interest, $145.73. That's the $2.86 plus $30.35 plus $45.59 plus $66.93. Does that work out? $45.73. We are 4 minutes early for our second break, but let's do that right now. It is 7:16. Let's come back at 7:26. Time for you guys to try one. Time for you to try one. I know. So we're looking at Carrie. Borrows $7,200 on November 28th at 12.25%. On December 26th, Carrie pays $2,000. On January 19th, Carrie pays $2,500. How much does Carrie pay on February 21st to pay off the loan? I'll give you guys a few minutes to play with that. Okay, first of all, somebody want to look up the dates for me? The day number for November 28th? 330 what? 32. December 26th? 360. And January 19th, of course, is 19. February 21st? 52. So, December 26th, we've got to do 360 minus 332 is 28 days. I equals 7,200 times 0.1225 times 28 over 360 gives us interest of 6860. That's going to be added to the 7,200 to get 7,200, $68.60. That's our balance before the payment. And then subtract $2,000. $5,268.60 is our balance after. And then, bless you, January 19th is $2,500 payment. Now, we have to do a double duty here for our date. We do 365 minus 360. That's 5 days. Why did I do that? 5 days left in the previous year. To that, we're going to add 19 for January 19th, makes 24 days. So when we go from one year to the next, we have to finish out the previous year. So that's the 365 minus whatever the number is for the last day we used. And then we add the days in the new year to it. So our interest, $5,268.60 times 0.1225 times 24 over 360 is going to give us an amount of $4,303. Does that look right? So to that, we're going to add that to, of course, the 5268.60, which gives us a balance before our payment of $5,311.63. And we will subtract $2,500, which gives us $2,811.63. What's next? February 21st, and what happens on February 21st? Maturity. So February 21st was 52 minus the 19 is 33 days. So I equals 2811.63 times 0.1225 times 33 over 360 gives us $31.57. We'll add that to the $2,811.63. Gives us, something's a little off there. There we go, $2,843.20. That is what is due on the 21st. Now, I didn't ask you for the total interest. If you were to look for it, if I were to ask for it, it would have been $143.20. Works for me. That looks about right. Any questions? Not quite yet. Remember, the test, I'm going to make you work on it for a week. Then I'll answer questions. I know. How do you keep a student in suspense? I'll tell you next week. Okay. Sorry. That's not right. Okay, so some of what we've been doing has been investments and savings accounts. Some of what we've been doing is a loan. They're interest-bearing notes. And there are two types of interest-bearing notes. There's a simple interest note, which is what we've been talking about. In a simple interest note, you start out with principal. Somewhere along the line, you add in interest, and that gets you to maturity value. Now, on every note, there is a stated face value. Like the one we just did, that was a $7,200 note because they borrowed $7,200. That's the face value. On a interest-bearing note, the face value is the principal. There's something else called a simple discount note. In a simple discount note, the face value is at the end of the note. It's the amount paid back. You can think of it as the maturity value. So if it's a $7,000 note, you're not getting $7,000, you're paying back $7,000. From that, you are deducting something called a discount. The discount is basically your interest. And you're working backwards to something called the proceeds. Now, the formula for interest was I equals principal times rate times time, where pre is the principal. The formula for the discount is also principal times rate times time, only it's face value times rate times time. Now, you won't see me write in face value. I'll probably just write in principal times rate times time. But remember, here the principal is this beginning amount. Here, the face value is really the amount at the end. We're working backwards. So let's show you just one quick example of what that all means. An $8,000 note at 8% simple interest for, oh, let's go 90 days. Now, I don't say exact or ordinary, so we assume ordinary, 360. A simple interest note, which is what we've been talking about. You receive how much money? $8,000. There's interest figured in. I equals 8,000 times 0.08 times 90 over 360. Come on. Which is, let's, 160 bucks. Yes, no. 160 bucks. $160 in interest. You will pay back $8,000 plus 160, $8,160. So that is the storyline for a simple interest note. If it's an $8,000 note at 8% simple interest for 90 days, you get $8,000. You're going to be charged 160 in interest, so you will pay back 8,160 bucks. If it is a simple discount note, how much will you receive? We don't know yet. The 8,000 is the face value, and the face value in a simple discount note. Okay, we're gonna get back here. There it is. A simple discount note is the amount you pay back. So at the end of this note, you're going to pay back $8,000. An $8,000 note, if it's a simple discount note, means you're paying back $8,000. Your interest is still $8,000 times 0.08 times 90 over 360. Guess what? That's the same amount. The amount you receive is referred to as your proceeds which is the 8,000 minus that discount. This is referred to as a discount as the interest. $7,840. Exactly. Which is a better deal for you if you're the one borrowing the money? The simple interest note. Either way, you pay the same interest of $160, don't you? So why is the simple interest note a better deal? Yeah, you actually get $8,000 to work with. Whereas in the simple discount note, you only get $7,840 to work with. So you pay the same amount of interest, but in the simple interest note, you get more money. Why on earth would you ever do a simple discount note then? Because that's the value of your collateral. If you have an item that is either worth $8,000 right now, or at the end of the 90 days will be worth $8,000, then the bank doesn't want to give you interest on top of that. They want to make sure that if they take your item, they're going to get their full amount back. So your item's worth $8,000, so they're going to look at it and say, okay, if you don't pay us back, we're going to get $8,000 from either way. So we're only going to give you the $7,840 so that your collateral is worth what you're saying it is. Now, most of the time, this isn't like, this would be if you go in and sign your car title loan or something like that. Normally, they're not going to give you full Blue Book value, though they're going to give you like 70 or 80% of Blue Book value, and then they're going to discount that amount just to be safe. Most of the time, what that collateral is money you've got coming in from something else. Let's say you're a contractor and you have a job that's going to be finished and you got this much money that's going to be coming in for that job, but you need to make payroll. So you're going to borrow money for a short period of time to make payroll, knowing in the bank saying, okay, you're going to get $8,000 coming in for this job. Once you get the $8,000, hand it over to us. So we're going to discount that amount and give you this much as a loan. Make sense? The last problem I want us to look at tonight is this. A car loan. This car loan is $30,000 at 8% simple interest. To make it simple for us, your monthly payment is $600. I want to do two scenarios here. Scenario one, you make payments on day 1, day 31. Actually, let's do it this way, just to keep the math from getting weird. Make a payment on day 0, day 30, day 60, and day 90. Scenario 2, make a payment on day 0, another payment on day 0, a third payment on day 0, and a fourth payment on day 0. I want you to find for each of these the balance on day 120. Let me help you through this once. I'll do the first payment in each. Well, I'll do the first two payments in each with you. So in the first one here, day 0, our interest is nothing, right? So you take $30,000, you subtract the payment of $600, $29,400. Correct? Hey, Superior, can I have somebody pull the door shut so the noise isn't coming in? Thank you. The second payment then being made on day 30 is going to be interest. Of course, that's why I did it day 30, so it's just a simple 30 days interest. 29,400 times, what did I say for a percent? 8. So 0.08 times 30 over 360. So that is going to be, oh, that did not work. $196 in interest. So we add that to the 29,400. That's 29,596. Then we subtract the payment of $600. So our balance, $28,996, correct? So that's what we're going to use then to start out our next payment. I'll let you finish out that one, and then we'll talk about the other scenario in just a second. So find the balance due on day, the balance of the loan on day 120, continuing with that. So how much is the interest for the second month? 196? Shouldn't be 196 again.
I'm sorry, 193.31.
193.31, okay. So we're going to add that to the 28,996.0, right? So it's 9, 18, 11, 9, 29, 189.31. And then we'll subtract the payment of 600. That's going to give us a balance of 28,589.31. That's where we're going to start day 90. Interest on 28,589.31 at 0.08, 30 over 360, gives us interest of how much? 190.60. We're going to add that to the 28,589.31, which is 28,779.91. Subtracting the 600 is 28,179.91. And then day 120, we still got to do more interest. So 28,179.91 times 0.08 times 30 over 360 gives us how much? 180. Heel taker. $187.87. Perfect. We add that to 28,179.91. $28,367.78 is the balance on day 120. Now, we're going to do the second scenario here very quickly together. Started out at $30,000. We make a payment of $600. We're at $29,400. Second payment, still on day 0. $29,400 minus $600 is $28,800. The third payment starts at $28,800 minus $600, $28,200. The fourth payment starts at $28,200. Come on. Minus 600, and you are correct. Is it 27,600? Now, the balance on day 120, I've got to figure out the interest on 27,600 because that was paid off at day 0 times 0.08, but now it's 120 days over 360. Gives us $92.26. That right? No, that cannot be right. 276 times 0.08. 736. That's better. $736. So we add that on to the 27,600. That is $2,800 or $28,336. Notice we have paid $31.78 less in interest. The reason is because when banks do car loans, we said that they calculated on simple interest, right? You making your car payment triggers the interest calculation. Banks absolutely hate it when you do what I just did here. They want you to make that payment every 30 days or 31 days. But if you make a whole bunch of payments all at once like this, then it sits there for like 3-4 months with no interest being calculated because you're not making a payment. They absolutely hate that. Now, $31 in interest difference isn't a big deal, but it's the fact that they're sitting there with interest building up that they don't have on their books. I get my tax refund every year, and I make my car payments for the year. My bank hates it. I get that notice every few months. You have not made a payment. We realize you don't owe us anything until, but we wish you'd make a payment. In fact, a lot of banks now actually have rules against this. Most banks, you cannot pay more than 30 days ahead. If your next payment is not due within 30 days, they won't let you make a payment. They take the payment, they'll apply it to the principal, but it doesn't count for the payment. Other banks won't let you go more than 2 payments ahead. If you're more than 2 payments ahead, they apply any payments to the principal. So I know people have been in trouble. They thought they've made like 4 payments so they can relax for a few months. Well, 2 months down the road, the bank is saying, hey, your payment is late. So just something to consider. One of those things to ask about when you take out a loan is, am I allowed to make payments ahead and how far ahead? Because one of my loans right now, 30 days ahead is as far as you can go. Yep. Most types of loans now, regulations have made it illegal to have early payment penalties. But they can make it just so you're not allowed, your early payments go towards principal rather than payments. There is a new homework that is due for next Wednesday. There is no quiz because we didn't have any homework from last week. Next Wednesday, I will try to make sure there's time that we can answer questions on the test for you. I do want you to struggle with it for a week to see if you can figure them out first.